Hello everyone and welcome back to another competitive programming video. Today we'll be taking a look at a British Informatics Olympiad question. It will be the 2012 question and question 2 from it. So let's have a quick look at the question first before I go to the whiteboard and explain my solution. Okay, so as usual I've highlighted the important parts in this question, since with these question 2s the majority of the problem is just trying to understand the statement. Okay, I'll let you have a quick read. Feel free to pause the video. Okay, nice. So now, I think with this particular question, there's not really much which needs to be explained in terms of the algorithm which we will use, since the question has outlined exactly what we need to code pretty clearly. But then the challenge with this question, and the reason why it's question 2, is because the actual issue comes with coding this. So now let's have a look at our code. So broadly, I've created two classes, one class for a point and one class for the grid. So we'll start the point class. So what the point class does is it's basically each of the junctions inside our train track. Each of them is a point, and the grid is basically just made up of each of these 26 points, okay? And this particular code is just whatever the input is, and the input in this case is all the lazy points, and we'll just be passing these as parameters to the grid class, and then we'll perform the play function within the grid class. This play function will be the kind of the body of the code, but more on that later. For now, let's have a look at the point class. So with these question 2s, I would highly recommend you doing something similar, like always create classes when you can, since it really makes the code easier to understand for yourself mainly, and also for others in case like others are looking at your code, but mainly for yourself, since these codes are often like up to 100 lines long. Some of them in the more recent years are even like 200 lines long. So it's very easy to get lost if you're coding this in like an hour, which you will in the actual exam. So anyways, we start with initializing some properties of this class. So the point is defaulted to being lazy. If it's not lazy, then we can change that later on. And now what this does is it also has, each point has a particular character associated, A, B, C, D, etc. And it has neighbors. Now these neighbors are the one station which is next to it, which is connected by a straight line, and then the two which are connected by a curved line. And then we also have this point set. Now this point set is just the particular neighbor which is set to that particular point. Now we also have this getNext method. So what this does is it pretty much decides what the next station which you should exit, or which you should go to after the current point which you are currently at is. So we assign the value of the point set, which is initially the empty string, but whatever the point set is, to this old variable. And remember, this point set is basically, for a lazy point, it's whichever point was previously set as the default way for exiting inside the curved path. And then we basically get the index of the particular old point set. And then if the point is lazy, and if the point end is not equal to old, remember, if you go back to the question, then we're basically entering this case is that if we enter through the curved portion which is not on the set portion, then what we do is we basically need to alter the particular set point. So then the point set becomes the curved, neighbors, and then 1 minus end. So end can either take 0, 1, so 1 minus end would just be the opposite value. So if it's 0, it would become 1, if it's 1, it would become 0. And then that would become the new point set. Now if the point is not lazy, then it's just a flip-flop. So by default, we just flip it. So it just was 1 minus end, and then we return the old. So now, because the old will be the, will basically be the point which it will exit out of, but then we're just updating the point set, so next time it enters the train track, it knows exactly which point to now exit from. And then that's all if it's entering through the straight track. If it's entering through the curved track, then it basically has to leave through the straight track, right? Since there are two curved tracks, but there are only one straight track, which go through a point. So then we return the straight and then the first element from the straight. So that's basically the point method, point class, sorry. And now let's have a look at the grid class. So what this does is this has 26 different points inside it, or 24, or like however many stations that we have. And we basically create one class for each of the points. And if the point is not lazy, then we set the lazy value to false. That's pretty self-explanatory. And now what we're doing over here is we're using the ASCII values, like the ASCII representations of these characters. So capital A will be represented with 65, B 66, C 67, etc. So then this basically, the reason why we're doing this is it's much easier to like access a particular value based on its ASCII value, since, for example, like if we want to go to the fifth station, which is letter E, then we can just do 65 plus 5, since that would give 70, sorry. And then that will basically, if we subtract 65 from that, that'll be the index inside our array. And then it's much easier to access all the different stations like that. So then after that, we basically do this initialize function, which is, this is the main bit of the code. I'll come to this shortly. And then we initialize the moves to whatever moves and current to whatever current values. And then these two values are basically just the initial values, which are set to being lazy, and also how many moves we need to perform. Okay, so that's the initialize function. That's the initialize method. Now we'll go into the initialize function. This is the main bit of the code. So what this does essentially is, if you remember back to the question, it creates this framework of train stations. Since all of these values which are present, for example, like A is connected to D and then A is also connected to E and F, we need to represent this with code. So what we do for the first four values, A, B, C, and D, we append the straight section to having 68 minus I. So what this does is, if we go back to the question, then it goes 68 minus I. So the reason for this is because A's straight section connects to D, so A's ASCII value is 65, so 68 minus 65 would be 3, and index 3 there's D. And now it would work the other way around as well. So for D, 68 minus 68, it would go to 0, and at position 0 there's A. And now it would work the same with B and C, so that's how we get the straight section. And now the way in which we get the curve section is, if we go back to the code, the question, notice that A connects to E and F, B connects to G and H, etc. So the first value connects to 5th and 6th, 2nd, 7th and 8th, etc, etc. So what we do is, we basically do, we extend the curve section to having two values. This is 69 because 69 is the ASCII value for E, plus 2 times I, and then 70 plus 2 times I. So the reason for this is because 2 times I is 2 times the current index. So let's say if it's at A, then it will be 2 times 0 plus 69. So the 69th and the 70th. And then if it's at B, for example, it would be 71st, 72nd, etc, etc. So that's how we have the first four properly finished. And now we basically go to the next lot. So now, if you notice, we have R1, R2, R3, and R4. So these are the 4 rows. Now we go to the second row. So the second row is basically the row of E, F, G, H, all the way to L. And now for each of these, it has a curved section, which is assigned to whatever the corresponding above value was. And therefore, inside this, the straight section is whatever this bit of code is. So it's I plus 1 if I is even, otherwise it's I minus 1. and then that value in R4. And now the reason why we do this is because R4 is is basically these 4 different values, and then those will correspond to the values ranging from E to L. And then likewise we have functions for the straight sections, and then the curved sections as well for R4. And now we basically go to the second row, and we have something similar basically. And then likewise for the third row. I'd highly recommend that you play around with these functions, since they do involve quite heavy ASCII use to generate these. An alternate way of generating these is if you just hard-coded everything, but that would be highly impractical. So, which is why I've chosen to implement them this way. Okay, now let's go and look at the rest of the code. If you understood this, good job, that's like 80% of the actual code. And now all we have to do is the play function, so we iterate through the number of moves which we have to perform, and then we get the 2 points from the current points part of our code, and then we basically just have to move between the 2 index values. And then what we do is we get the first index value from the grid, and then we perform the getNext method to get the second one. And then the current points is p2 plus p. So p is whatever the next value is, and then p2 is our second point within here. And then we print our current point, since our current point is whatever the current point which we are currently on is, which is what the question demands us to print. So that's pretty much it for this code. I really hope you enjoyed listening to the solution for this code. If you learned something new, please be sure to leave a like and subscribe. It would be very much appreciated. And also please feel free to check out my GitHub if you would like to play around with this code. And thank you very much for watching. I hope to see you in another video next time. Thanks. Bye.